Greetings from the set of Metro and More at Metropolitan Community College, serving more than 50,000 students with over 120 programs at our 8 locations in the daytime, evening, weekends, or online. Hi everybody, I'm Kent Pavelka. Welcome again to Metro and More. More of what you need to know about Metropolitan Community College. Our discussion in the next 30 minutes all about MCC's Fort Omaha campus expansion project, and in specific the Central Utility Plant. Our guest, Stan Harrell, who is the Director of Campus Planning and Sustainability, and Ron Feuerbach, the design engineer for all of this with Morrissey Engineering. The $90 million project at the Fort Omaha campus includes the construction of 3 buildings aimed at better job training for students in the fields of the trades and technology fields. This will provide an additional 250,000 square feet of learning space, extending the campus to the south at the Fort Omaha campus. And a vital but little known aspect of all this is the thing that will keep these buildings up and running, the Central Utility Plant, and we're here to discuss that with Stan and Ron. A little bit, Stan, let's have you break the ice here.
Sure.
Reiterate a little bit about yourself, your career here at MCC.
I'm Director of Campus Planning for the college, and I've been here about 17 years at this point. I started as a project manager in facilities management, and when we kept moving through the expansion of the college, my career kept moving as well. So essentially, this Central Utility Plant that we're talking about today is the result of some careful planning at the beginning of this project, where we began to realize that we could realize some efficiencies by placing all of this equipment in one location instead of having all of the separate mechanical systems in each building. We still have mechanical systems, some mechanical systems in the buildings, but essentially we're providing hot and cold water to these buildings for the heating and the cooling of them.
Sure.
So,
Ron, what's your background?
My background
Tell us about yourself and about Morrissey.
We'll do, Kent, I'm a University of Nebraska graduate who am practicing in the consulting field for about 40 years. I've been with Morrissey Engineering for 10 years, the last 10 years, and I've got to work for Metro Community College projects for about the last 15 or 16. So the Central Utility Plant was a fun project to be involved in, and we're very proud of it.
So your involvement with MCC predates
Yes.
your hire date at Morrissey.
It has. I've been involved in a few other projects along the way. Yes.
A true partner with Metropolitan Community College. Tell us about the work Morrissey does.
We're a mechanical, electrical technology design firm. We do mechanical engineering design, HVAC, plumbing, fire protection. We do electrical engineering design, power distribution, telecommunications. We have a low voltage group that does data and power, or data and telecommunications. We also do commissioning. We have started that up, and commissioning is a big part of the future in sustainability.
What is commissioning?
Commissioning is where you go into a building after it's completed and run all the systems through their paces to make sure that they were not only installed but actually operating as intended in the design. Mm-hmm. So it's like a final check to make sure everything is properly operating.
Well, let's jump in here and talk about what's going on at the fort. A $90 million project. I think this represents what, less than $5 million of that $90 million?
Yeah, it is. It's the project itself. The Central Utility Plant was, I think it came in around $4.3 million. We've ended up burying about a mile of pipe connecting this plant to all of the buildings on the campus. So we had to do this work while we were engineering the site to get these buildings ready. We've got the 3 buildings. One of them's a construction education center. That's around 100,000 square feet. We've got a Center for Advanced and Emerging Technologies. That's probably around 70,000, something like that. And then the remainder is in a 3-story academic skills center that we're building at the same time.
Well, let's talk about each one of these buildings separately.
Sure.
Let's start with the Construction Education Center, and you know what its function is, what it will do, what it will provide, and how it ties into what you needed to do with the Central Utility Plant.
Sure. Traditionally, the college has had its trades program, the building and construction trades program, split between several campuses. And during our master planning process, it was decided that we needed to co-locate some of these programs in one location. and the college has worked diligently towards that goal since then. It will bring our HVAC, architectural drafting and design, and our civil engineering from our Elkhorn campus. It'll bring electrical, plumbing, and construction technology from our South campus, and our masonry and a couple of other programs from our ATC campus. So they're all going to be co-located here in one location so that we can train the future workforce here in Omaha in the construction
And when
area.
you two sat down and discussed the Construction Education Center, what unique requirements did it require regarding a central utilities plan?
Well, from the central utility standpoint, it was like in any normal building, but what the challenge was with the education center, the construction education center, was setting up systems inside the building that can be used to teach the various technologies that the students need to take forward in their careers. So there's a space there where there'll be furnaces, rooftop air conditioning units, all of those will be set up inside the building, and it had to be designed so they could operate inside the building. So the central plant had to be designed to be able to cool and heat those areas when they're doing cooling and heating and putting heat into the space. So it was a challenge.
Additionally, our central utility plant here is another teaching tool.
Mm-hmm.
The college is going to focus more strongly than it has in the past on commercial heating and air conditioning. So this central plant is yet just one more aspect of that teaching ability. So we'll be able to bring students through here and explain fully functional
It'll be a classroom.
installation.
It is.
Yep,
Yeah.
it is a classroom, and that's how it was set up to begin with. That's why there's as much space in it as there is. And I'll have to say that the tradespeople locally and the Kiewit Building Group in particular have really done an outstanding job making this a classroom-worthy.
facility, yeah. It
I mean,
is.
everything in there straight plumb level, the way it's supposed to be all the time, and it's just a beautiful example of craftsmanship.
And you're looking at a shot of it here. We're going to talk
Sure.
more about the CUP, but let's move on to the Center for Advanced and Emerging Technologies. When you looked at that project, what considerations did you have regarding the plan?
Well, generally speaking, for us at the college, this is the college's opportunity to fully engage with local industry, and we wanted to have a building where we could have industry come into the building itself, not only for exhibits, but actual working partnerships with equipment where we can train incumbent workforce and our students at the same time. So we've got several large areas within the Center for Advanced and Emerging Technologies, and they had their own challenges with heating and cooling. Maybe Ron wants to speak to that.
Well, yes, this is a real challenge in this building because we're designing for the future. But we don't know what's coming down the road. It's going to be new systems that come in, they get tested in there. So we had to put a lot of flexibility into our design of this facility. So,
Well, how do you plan for something you don't know what it is?
well,
Space?
space and capacity of cooling, capacity of heating, lighting, technology. We have a lot of technology in the building, a lot of, computer connections, Wi-Fi, that type of thing. You give it our best look in the.
Yeah, and a couple of real quick specifics. We have an academic data center, so we'll have a state-of-the-art data center within the Kate building, as we call it for short. And additionally, we have about 8,000 or 9,000 square feet dedicated to makerspace and fabrication labs. So you'll be able to take designs, computer designs from conception clear through completion within that facility. So it's specifically set up for prototyping products is what it's for.
So many
And-
challenges.
Yeah, the Academic Skills Center.
I can speak to that
Yeah,
quickly.
sure.
Generally speaking, a lot of the students, especially what you would consider to be normal college-age students at the college, don't come as well prepared for college work as they really need to be. And a lot of them don't understand as fully what their career path might represent. So our Academic Skills Center is twofold. One of the functions is to introduce them to all of the programs throughout the entire Metro Community College system, what's available on a career choice. And then the other piece is to make sure that they are well grounded. We give them a great first year experience and get them up to speed on any particular skill sets that might be lacking so they're available to do college level work. So we've got extensive testing centers, we've got writing centers, we've got computers centers, we've got math instruction centers. So it's really set up to fully ground that first year student in the experience of going to college and help them get through that.
Of the 3 buildings, was this the easiest one to kind of plan for?
I would say so, because it's a classroom building, and there was a lot of technology that went into it, however, and that was always challenging. But yeah, it was, of the 3, there was less demand on our part.
Which, of the other 2, which one was the most difficult?
I think the Kate was probably, now you're gonna give me trouble here now.
No, don't mean to.
No, I'm kidding. The Kate building, because we were having to design for whatever future possibilities were, that took more of a challenge. We had to have a crystal ball to kind of see what is down the road.
Right.
So,
Well, just address that a little bit. What did you come up with? I mean, as far as premonition, as far as the future is concerned. And
I think some of the technologies that are out there that are going to be very interesting are 3D printing. They do a lot with that already.
Right.
But we're looking at being able to take a manufacturing process from conceptual phase to how they develop and eventually create this development, and to work with industry partners to make that happen is what I understand.
Well, we'll use the academic data center, for instance. Omaha and the surrounds is becoming a pretty active data center for a lot of national and international companies. And this data center that we put in has state-of-the-art equipment for cooling that system and tracking it and making sure that it is what it's supposed to be. We might have talked about this in a previous session, but the college has also, within the last year or 2, installed its own fiber optic network that connects all of our campus locations and the Scott Data Center, where we have pushed some of our computing out to. And so we'll have those fibers coming into that Center for Advanced and Emerging Technology. So the college is not really going to be limited bandwidth-wise on what we can do in that academic data center, but that requires a whole host of mechanical and electrical equipment on the back end to make sure that that runs right. And we'll be teaching data center operations in that building as well. So we're trying to get down to the technician level, supply them with all of the learning tools that's required to obtain a modern job.
Well, let's look inside the CUP, Central Utilities Plant, and you can explain what we're looking at here.
Okay.
We've got it on the monitor here. We'll look at some video we shot too.
Certainly. Well, what is installed in the Central Utility Plant to serve these 3 buildings are a system to make heating water, which are our boilers here, and on the right you can see there are 3 million BTU per hour boilers that generate heating water that is then pumped through the underground piping system that Stan referenced out to each building. On the left in this picture are 2 500-ton electric-driven centrifugal chillers, which generate chilled water that is piped to each building for cooling of the building.
So the water is hot and or cold when it leaves the CUP?
It is.
Yeah.
The heating water will be somewhere between 100 and 140 degrees, and the chill water will be pretty steady at 45 degrees for cooling. So the pumps you see in the upper right-hand corner are the pumps that pump the water out to the various buildings through the underground piping system. One thing that you will notice in this picture on the upper left, there is a space in there for future equipment.
Mm-hmm.
We've designed the plant to be expanded to be able to use newer technologies that come along, possibly. There are
an additional bay, if you will.
Additional bay, if you will, and there is one outside as well for adding equipment. And there are, planned. The piping system was designed to be expanded to any future buildings that this plant could serve, and it's all ready to go. And hopefully in 5 to 10 years, there'll be some new interesting technology that can be installed and used.
Yeah, one thing I think you should probably reference, Ron, talk about those chillers for a minute. There's a new technology in how those chillers work that's really pretty interesting.
It is. We tried to look at new technologies that hopefully the students will be able to benefit from. These chillers are centrifugal-driven chillers, which has a rotating element in them, but chillers in the past always had bearings which required oil, and you had to have oil pressure.
Kind of like the crankshaft in your car.
Exactly.
Mm-hmm.
And these are magnetically levitated. They actually have a device, an impeller in there that rotates to create the cooling that levitates in a magnetic field, so there's no friction, therefore no oil. And these rotate.
Therefore they don't wear out.
That's correct. They're called maglev chillers, if you will, magnetically levitated, and it has one moving part that is with no friction. So they're called frictionless magnetic drive chillers, and it's quite a technology, and they really perform well at part load, what we call part load operation, where we can reduce the speed and really take advantage of the efficiency of the machine.
Talk about state of the art here.
Oh, it is. It is definitely state of the art, and you know, they're extraordinarily quiet, and really energy efficient.
They are.
So it's definitely state of the art.
And the boilers too, just to expand on that, are high efficiency condensing boilers. They can get up to 92% efficient, and they actually condense part of the products of combustion so that we can squeeze every bit of heat out of the natural gas that is burned in the boiler. So the system is all controlled by a direct digital control system that is connected to the campus-wide internet, and operators can actually operate this plant from their smartphones.
Is that
They have
in this
connectivity.
building?
It is. There's a control center on the north side. It's out of the picture here, but in there is all the direct digital control components that will control each piece of equipment and monitor and meter every bit of energy that goes out of the plant to the buildings.
Right.
Well, you say they can control everything with a smartphone. I
Yes.
mean, is that like a backup emergency, or is that what standard procedure? Or?
No, what could happen is something could go offline for any reason. These are smart machines, so they're going to turn themselves off before they damage themselves, right? So if you get that call and you're at another campus,
Oh, sure,
or
remote control.
remote
Yeah.
control,
Exactly.
you're going to be able to get on your smartphone, see what the problem is, see what the
Sure.
alarm is, and clear the alarm and re-engage the equipment. So I should add that this control room, the college has been working on its energy management systems for a considerable period of time, and we'll be able to, and already do, monitor every building in our entire campus system from this location. So. As well, the software that's being used here is pretty cutting edge
Yes,
as
it is.
well.
It is.
We've designed
Do
it
you
around.
do you buy it, or do you build it yourself, or how's
Well,
that
you
work?
buy a package, but it all has to be customized to match what you've installed in your plant, and that process has already happened, and so now they're all set up to run this plant and like Stan had a good point. This equipment will alarm if it has any problem, and the operations staff can dial in at wherever they're at through a Wi-Fi connection and check the problems. In addition, to increase the reliability of the plant, this plant has a 500 kilowatt generator outside that will maintain the operations of the plant even during a power outage, so we can maintain
Yeah,
heat.
and it's diesel, so as long as that tank is full, it'll run for.
Sounds like a
ever.
radio station.
Yeah, well, we
Seriously.
need
Yeah.
24/7, 365 operation out of this. We can't allow
Yes.
any of the
No.
buildings to get cold or freeze.
So the hot water gets over to the three buildings, and the cold water gets over to the three buildings, and then how does it heat and cool those buildings?
Well, inside the buildings, there are air handling units with coils in them, cooling coils and heating coils that will put air across the coils and take the heat out of the building or add heat to the building, whatever is needed. Those buildings are also connected to this control system, so the person sitting in this control room can monitor, well, the entire campus.
Right.
Actually.
Yeah. And
So-
additionally, that's one of the things that we're going to be teaching. That's why this central plant was so important. As we get more into the commercial HVAC phases of the learning that occurs in that construction education center, that energy management piece, that software piece needs to be taught as well. It's not, these are no longer buildings that you just change filters in and grease a few joints. These are very sophisticated modern buildings.
You talked earlier about the fact that all the design was, part of the consideration was to maximize space for learning.
Right.
What you're talking about here is if you didn't have this, then much more space would have been required for these purposes in the buildings themselves, right?
That's correct. If we didn't have this plant, we would have to have similar equipment in each of the buildings. And we've estimated that we've saved at least 3,000 square feet total in those three buildings by having the central plant located here to serve them.
Yeah.
So that space was captured more for teaching in those buildings than for our equipment.
And then you've got teaching in this building.
That's correct.
Well, and simultaneously, the maintenance factor is
Yes.
greatly reduced because you can do all of your maintenance on this equipment probably with one guy in one space, and you don't have to have that traveling between the buildings to monitor all of this equipment.
Yeah.
All of the connections that were saved, I mean, there is no doubt. Now, the other thing I'd like to add, if we got a couple of minutes
Sure.
here, the reason that this central utility plant is located slightly remotely from these buildings, it's actually located up next to our Fort Omaha, the center of the campus, up by our parade ground.
Right across the street from where we're speaking.
Exactly. And the reason that it's there is because we tested the capacity underneath the parade ground to bring on ground loop water to serve the central plant. And so down the road, if the college wants to, we can put in geothermal wells underneath our parade ground and connect them to this central plant and save even more energy. So that adjacency to the parade ground is how this building got placed where it is.
Thus this extra bay of space for that future technology.
Sure.
Right.
We talked a little bit about this, but the time and the environmental cost savings, all that went into your thinking and planning.
Yes, we sustainability and the college's commitment to sustainability was very important in all the decisions we made as far as equipment selection and how we ran the plant. But really, there was also a component of cost savings. We did many studies, and we felt that our last study indicated that we feel that the campus will save about 1.4 million life cycle costs by having a central plant as opposed to distributed equipment in all the buildings.
Life cycle meaning over how many years?
The owning and operating cost of over 20 years of this plant versus having individual equipment in each building.
And that's a very conservative estimate.
Very
in my-
conservative, yes.
Yeah. So where are we on the timeline? You haven't fired this up yet, right?
No, we'll take possession of it the way that things are set up now on the 11th of November, so roughly
Okay.
10 days from now.
So as we speak, it has,
Yep.
As we tape this, it hasn't
Right.
been fired up. Are you confident there won't be any bugs? Or
I'm confident that whatever problems do occur are easily handled.
Absolutely.
I mean, this has been well thought out, well executed, and I have no qualms whatsoever about this starting and working. Now, you mentioned the other three buildings and the reason for this. The reason that this building is further along than the other buildings is because we need this building this winter to provide temporary heat to those other buildings so that we can continue work over the winter without a much more expensive effort of propane heat for those buildings. So
otherwise, the target date for total completion fall of 17 isn't going to happen, right?
that's
If
probably
you lose
true.
the winter,
If we lose the winter, we're in trouble. So,
Yeah.
but we're on target and on budget to make all of this happen. And these other three buildings should open on schedule, fall 2017.
of all the four buildings, because we talk about three
Right.
primarily, was this the most challenging part or of the
No,
expansion project?
I think the most challenging part was just actually getting to the understanding of the benefits that this could provide.
I
I
think
think
so.
that's once we began our homework and started to really think about what would serve the college for an extremely long period of time, this became
Space saving,
right.
it provides additional classroom space in the
Teaching-
buildings
teaching
and
tool.
in this building.
Right.
Right. Redundancy, we were able to provide redundancy easier with the central plant
Yeah.
than having redundancy built into all three buildings.
Mhm.
And the energy efficiency by being able to use water-cooled equipment for cooling rather than air-cooled, which was probably what we would have done without having a central plant. So,
That's what we discussed before we went on the air. Is it's just like the old radiators in a
Yep.
sense. Isn't
Yep.
it?
in a sense,
In a sense.
In a sense.
In a sense, yeah.
Well, versus
with a modern twist. but-
With
Yeah.
Yeah, no, it's going to be a great thing for the college when all of these buildings are done and a central utility plant is operating. We're going to save utility money forever, essentially. We've got some possibilities for geothermal when the college decides to execute on that piece, and we will have state-of-the-art teaching tools throughout all of these buildings.
What were the most significant challenges with regard to putting this together?
Well, I would say, from my perspective, the challenge of getting all that piping, a mile of piping, as Stan said, underground in an Army fort.
Yeah, the site that we're working on, an existing site, was far and away the largest challenge. far and away. There were all kinds of non-treasures buried.
Well, and that was preliminary work.
That's a very good description.
In a sense, it was preliminary work, right?
Oh yeah. We
to
had to basically discover every utility line that we had to cross, every sewer, every sanitary, every water line. We had
Building
we had
foundation?
37 utility crossings to put this piping in that couldn't be disrupted. So
So to
Keep
get
it
all that
discovered those
piping
early.
in and keep every building in operation that we affected and went by was a challenge.
Is this like a model for the future for other businesses, or how can? I mean, we talked
I
about
think it's
being
a model for the
state-of-the-art.
college. I mean,
it's
it-
certainly a
colleges?
model for us.
Yeah.
The other thing too that we didn't mention, and we talked previous to the show, all of these buildings have been designed with Revit software, which is a 3D design tool nowadays. So you can actually view every pipe, every plug, every conduit that's in these buildings in real space before the work actually starts. So there was a considerable amount of coordination that occurred prior to these buildings even coming out of the ground that you just couldn't have done in the old days. And I think that's critical. I think that's really the only real way that we can meet our aggressive schedule is because all of these buildings have been modeled. So every duct work, every piece of duct work, every water line has been known where it goes in the building for some time.
And that saves time and money. How?
Because the guys in the field aren't in each other's way. That way the guy putting in the duct work isn't getting in the way of the guy putting in the water lines. You know, you don't have any conflicts. They're called architectural conflicts within the building.
You're right, the coordination, it takes out a coordination step that we used to have to do because now everybody sits in a room and looks at the model and sees every component where it goes in the building.
So it provides a timeline.
Shortens the timeline.
Shortens.
It
Shortens the
the
timeline, but
construction.
you can actually build a schedule off of it
Yeah.
as well.
Yeah.
Right.
Yeah.
Probably shouldn't let the whole show go without talking about collaborations. Obviously, Morrissey with MCC, but there was more to it than that.
Oh,
We
much
have a
more.
large team.
We have a large team, yes.
The executive architects on the project are Hall and Basham and Associates. We have also BNIM, who are helping on the Kate building. We have BCDM, who's a local firm that's worked with the college for a long time. They designed the Construction Education Center. And then Morrissey, through their various teams, has provided all the mechanical and engineering in all of these buildings, including the central plant. So it's a large team. Kiewit Building Group are the construction management firm at risk, and I would say on an average weekly meeting we have 15 to 20 participants in the room every week. So it's a large
team.
effort.
Have about a minute left. What haven't I asked you about that you want to share with our viewers?
I'll let Stan take
Well,
that.
you both take 30 seconds. Go
Yeah,
ahead.
I just think that this is a model for a good spend of public resources. This is going to serve the community long into the future.
Mhm.
So I'm proud to work here at the college and be associated with this.
And it'll pay back over time,
Yeah.
you know, by
And it
efficiencies.
equips you and Morrissey to, I mean, this has been a unique
Oh, it
experience,
is.
hasn't it?
We're very proud, very happy to be a part of the team. It was a very, very good project to be working on.
Very good. The new central utility plant at Metropolitan Community College's Fort Omaha campus. Thanks, gentlemen.
Thank you.
Thank you,
And
Kent.
thank you for being with us again on Metro and More. Our goal is to better acquaint you with the mission, leadership, and the reach of the college. I'm Kent Pavelka for Metropolitan Community College. If you have comments or questions about the program, please email us at metrovision@mccneb.edu. Thanks for watching.
This has been a MetroVision production produced by Metropolitan Community College.